Hey all you cool cats and kittens. Today you guys are going to learn how to multiply mixed numbers. And it sounds kind of hard, but I'm going to break it down into a good strategy for you to use. And I want you to think about how you could work this strategy every single time you come across problems like this. The strategy is actually using area models and partial products. So area models are those rectangles that we draw out, rectangle. And the partial products is actually just like breaking it down into its parts. So just like how it says partial part. All right, so we have 4 2/3 times 7. When would you ever have to do that? Well, if somebody in 6th grade asked you, what is the area of this triangle? Its measurements are 4 2/3 inches by 7 inches, for example. So you would have to multiply them. So the way that we're going to do that is we're going to break it down to its partial products. So basically it's 4 times 7. That's one of the partial products. 4 times 7. And we can figure that out because it's just a fact. 4 times 7 is 28. And then it's also 2/3 times 7. And I'm going to write that partial product right below it. 2/3 times 7. So it's both of these parts times that 7. The 4 times the 7 and the 2/3 times the 7. Okay? So now what is 7 times 2/3? Well, I could figure that out by making that into a fraction as well. And any whole number, when you want to make it into a fraction, you're going to put a 1 as a denominator. And now I can just do 7 times 2 is 14. 3 times 1 is 3. 14/3. I can change that back into 3 goes into 14 4 times with what left over? Well, 3 times 4 was 12. 14, take away 12 is 2. And I keep the same denominator. So with the partial products, now I'm just going to add them up together. 28 plus 4 2/3. And I should get 28 plus 4 is 32. And then the 2/3. And then if you want to look at the area model, you can just go ahead and draw that rectangle. And you're only going to have to split up one of these products, the 4 2/3, because it's actually in 2 parts. So I'm going to just divide that rectangle up into 4 and the 2/3 times 7. And 7 doesn't have a fraction next to it, so I can just go ahead and mark it as 7. So 7 times 4 was the 28. 7 times 2/3, well, remember that was 14/3, which is the same thing as 4 2/3. And then you add them up together, and you get 32 2/3. So that's how you do it when you have to multiply a whole number times a mixed number. Now, what if I have to do a mixed number times a mixed number? It gets a little bit more complicated, but it's the same exact strategy. This one, since it's a little bit harder, I'm going to actually draw out the area model first. So I'm going to break up the 1 3/4 into a 1 3/4. Now the reason why it's complicated is because these are both mixed numbers. So now I need to separate out the whole number and the fraction. So I'm just going to go ahead and draw a line here. Here's my whole number is 2. My fraction is 1/3. So down the side I have one of my products, 2 1/3. Across the top I have the other of the products, which is 1 3/4. Now I can just multiply the parts, just like when you did area models. 2 times 1 is 2. 2 times 3/4, that would be, well, 3 times 2 is 6, 6/4. So you can write that and then figure it out as I go along. That's 1 2/4, which everybody knows is the same thing as 1 1/2. Okay? And now again, I'm going to use the area model to figure out the other part. So it's 1 times 1/3. That's easy. That's just 1/3. Now it's 3/4 times 1/3. I could do that inside the box to show you, but I think it might be easier if you see it bigger. So 3/4 times 1/3. Those are easy because we did multiplying fractions a couple units ago. you just multiply across top. 3 times 1 is 3. 4 times 3 is 12. 3 twelfths. So that one is 3 twelfths. So now I figured out all the parts. My partial products then are 1 times 2 is 2. 3/4 times 2 is 1.5. 1 times 1/3 equals 1/3. And then 3/4 times 1/3 equaled 3 twelfths. And then my last step is to add up all the partial products. And this isn't easy because notice that they all have different denominators on them. So I need to find a denominator that would work for both a 2, 3, and 12. 2, 3, and 12. Well, I know they all go into 12 because I know I can multiply 3 times something to equal 12. That's 4. So I'm just going to go ahead and do that. I'm going to do 3 times 4, 1 times 4, because when you do the bottom, you have to do the top. 1 times 4 is 4. I'm going to turn this one also into a 12. 2 times 1 equals 12. Oh, that's 6. 2 times 6. When I do the bottom, I do the top times 6. That's 6 twelfths, 4 twelfths, and 3 twelfths. So I'm going to add that all up. And then I'm not going to forget my whole numbers, which are 1 here and 2 here. Okay? So 6 and 4 is 10, 11, 12, 13. So it's 13 twelfths, plus my 2 and my 1 makes 3 and 13 twelfths. And I don't like having an improper fraction, so I'm going to rename that one. So this improper fraction actually becomes, well, 12 goes into 13 one time, with 1 left over, 1/12, plus my 3 equals 4 and 1/12. And that's my final answer to that one. And I probably could have figured that out if I had actually, at least the ballpark of it, if I'd done an estimate first, which is of course what I should have done. So I should have rounded that to 2 times 2 is 4. So if I end up with 4 and 1/12, you can guess that's pretty close, and that's pretty accurate. And up above, if I had done an estimate, I probably would have rounded up to 5, because 4 and 2/3 is closer to 5. 5 times 7 is 35, which is pretty darn close to 32 and 2/3. All right, let's do a couple more problems together, just so you start to get the hang of it. All right, again, I have a tricky one, meaning I have a mixed number times a mixed number. So I'm going to go ahead and draw the area model first. So you draw your rectangle, and you're going to split it up into its parts. And it has this many parts, because I'm going to break up that 3 2/5 into 3 2/5. And I'm going to break up that 5 1/3 into 5 1/3. And I'm just going to multiply as I go along. So 5 times 3 is 15. That's one of the partial products. 5 times 2/5. Well, remember, I can call that 5 over 1. So 5 times 2 is 10. All over 5 times 1 is 5. 10/5. I know that 5 goes into 10 2 times, so that's the same thing as a 2. And now I have a 3 times 1/3. I'll just show you on the bottom down here what I'm doing here. 3 times 1/3. So again, I can just make that whole number into a fraction by putting a 1 under it. 3 times 1 is 3. 3 times 1 is 3. 3/3 is 1 whole. Well, that's handy. So this partial product is going to be 1 whole. And now I'm doing the 2/5 times 1/3. So 2/5 times 1/3. There's Mocha. You want to come in, Kate? You being camera shy? She's not supposed to get on the TV. So now I'll go ahead and do 2 times 1 is 2. 5 times 3 is 15. So that one's 2/15. I like this. This only ends up having like one fraction, which is easy to add. So when I write up my partial products, I'm just going to look at this and go, I did 3 times 5, and that equals 15. I did 2/5 times 5, and that actually equaled 2. I did 3 times 1/3, and that equaled 1. And then I did 2/5 times 1/3, and that equaled 2/15. Adding it up is going to be very easy. I'm just going to box this out so you can see that easier. So it's 15 plus 2 plus 1, so that's 18, and 2/15. And let's see if that checks out with my estimate, which I'm going to do right now. 3 and 2/5, well, that would round up to 4. 5 and 1/3 would round to 5, so 4 times 5 would be 20. So that is really close. I'm pretty sure I got that right, 18 and 2/15. Okay, one more. All right, 4.5 times 5, 6. Oh, I like this. It's only one mixed number and one fraction. So when I draw up my area model, I only have to break up one of them, because this is actually 2 parts. So we're breaking apart the whole number and the fraction. So I'm breaking that into 4 and 1/2 times 5, 6. And this time I'm going to go ahead and do the estimate first. I should have all along. 4.5, I'm just going to round that up to 5 times 5, 6 is close to 1. 5 times 1 is 5. So I wouldn't be too surprised if I end up getting something very close to 5. All right, so first of all, let me just start over here. 1/2 times 5, 6. 1/2 times 5, 6. 1 times 5 is 5. 2 times 6 is 12, so that's 5/12. And then I have my 4 times 5, 6. And I know if I'm multiplying a whole number, I'm just going to go ahead and put it over 1. 4 times 5 is 20. 6 times 1 is 6. 26. Improper. We don't like that, so we're going to go ahead and divide that up. So that goes in there 3 times. Let's see, 6 times 3 is 18. So 2, 6. So this partial product is 3 and 2, 6. And I'm just going to show you how the partial products work out. It's 4 times 5, 6 equaled 3 and 2, 6. And then 1/2 times 5, 6 equals 5/12. Now I just have to add up my partial products. And I can't right away because I have a 12 and I have a 6, so I have to turn them both into, well, I can turn a 6 into 12, so I might as well just do that. 6 times 2 equals 12. So what I do at the bottom, I do the top. 2 times 2 is 4. So I'm just adding up my 4/12 plus 5/12, I get 9/12. And then my whole number, I can't forget that, is 3 and 9/12, which I know I can put that in the simplest form as 3. And let's see, I can divide them both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. It's 3 3/4. And my estimate was going to be close to 5. I have 3 3/4. I think that's pretty good. All right, I'm going to show you how to do one of the problems on the journal pages, but your homework today is going to be doing journal pages 233 and 234. So I might as well just take a preview of that with you. It says for problems 1 to 3, use a rectangle to make an area model, label the sides like I was doing there, find and list the partial products, label the partial products in the area model, add the partial products to find your answer. You may need to rename fractions with a common denominator. Okay, so I'm going to look for the hardest problem to do on page 233 and 234. Ooh. I should probably do one of these word problems. Alright, let's do that. Let's do one of the word problems because I feel like the other ones are pretty self-explanatory. If you watch my video again, you can go back and see. Gina is cleaning her closet and wants to know how much floor space she has. Her closet floor is 3.5 feet by 4 1/3 feet rectangle. What is the area of her closet floor? So when you find area, you know you have to do length times width. And let's just show you how that part is going to be broken up. Using my area model. This is 3 1/2 times 4 1/3. It's my area model equals A for area. So I'm going to break these up. So since they have two parts, a whole number and a fraction, here I'm going to break that up into 3 1/2. And then there's two parts here. There's the whole number and the fraction. I'm going to break that up into two parts, 4 1/3. And then I just go ahead and multiply all of the parts. So I have my 3 times 4 is 12. 1/2 times 4. I can do that one in my half because 1/2 of 4 is 2. Okay? And now 3 times 1/3. I can do that one in my head again too, because I know that if I have 3 1/3 cups, it's the same thing as a whole thing. The 1/2 times 1/3 I might write out. And 1 times 1 is 1, 2 times 3 is 6, so that one is 1/6. So if I write out all my parts, I have a 3 times 4 equals 12. I have a 1/2 times 4 equals 2. I have a 3 times 1/3 equals 1, and I have a 1/2 times 1/3 equals 1/6. And of course, my final step is to add them all up. 12 plus 2 is 14, plus 1 is 15, 15 1/6. Now, in this case, they gave us the unit. They were measuring by feet. So I'm going to add the unit on there, feet, and since it is area, it's feet squared. So it's 15 6 square feet. Okay, so you are lucky. I just did number 5 with you. If the kids are trying to skip out on not watching my video, they won't even know how to do that one. They have to figure that one out on their own. Number 6 is write a number story that can be solved by multiplying 1 4/5 times 6, then solve. We talk a lot about using these as multiplying to find area. So you can make up an area problem. You can also think about what would you have 1 4/5 of. Let's say the recipe called for 1 4/5 cups of flour, and you wanted to make 6 batches of that. That's a case where you would definitely be multiplying 1 4/5 times 6. So with measurements, I know people don't usually measure flour in 1 4/5 increments, but who knows? That is just another example of when you're going to have to multiply something like that together. All right, so that is how to do multiplying mixed numbers using area model and partial products.